Hey friends, this is going to be the video for the dilations review. So we have 5 questions here once you get logged in. And our first step is we always need to start with which one is our original image and which one is our ending image. And we know that our ending image always has that little prime mark or that little apostrophe on it. So our starting image is just regular letters. Like on this one, we have D, E, and F. And then on our ending figure, we have our prime mark of that apostrophe. So we have D prime, E prime, and F prime. So now that we know which one is our beginning figure and which one is our ending figure, when we go from large to small, that is a reduction. If this was our beginning picture and we went from small to big, that would be an enlargement. So this is a reduction. Now, how do we figure out what is the scale factor? Well, we have to look at our coordinates of our points. If we want to, on this one, let's use this D point here. And in this, our original D is at 5, 10. So we have our X and our Y, and our D prime is at 1, 2. So we have to look at how do we get from our original point of 5, 10 to 1, 2? Well, we know it's a reduction, and to reduce, we're going to have to divide. If we were enlarging, we would multiply. So how do we get from 5 to 1? What do we divide our original coordinates by, our 5 and our 10, to get the answer to be this 1 and 2? Well, 5 divided by 5 is 1. And 10 divided by 5 is 2. So our scale factor is 5. So we would come down here, find 5. Find 5, and we hit next. Here we have 2 parallelograms. We need to figure out which one is our original image and which one is our ending image. Well, our smaller image is our original image because it doesn't have that prime mark, but our big one does. And so we know that if we go from a small figure to a large figure, that is an enlargement. Because think, to go from small to large, there's the word large is right there in enlargement. So now we just need to look and see what are our original points. Well, which we'll use M. So our original M point is at -1, -1. Whoops. And M prime is at -3, -3. So how do we get from -1 to -3? Sorry. So on here, we are enlarging. So with an enlargement, we multiply. So what do we multiply -1s by to get -3? Well, it's 3. So we click option 3 here for 3. Well, and let's see what we have next. All right, so on number 3 here, we need to decide which is our original and which one is our ending figure? Well, our original one is this bigger one because it does not have the prime marks. And we can see that this smaller figure has the prime marks. So let's pick a point and let's start working with it. So our original J is at 8, comma, 4, and J prime is at 4, comma, 2. So we can tell that if we go from the big shape to the smaller shape, that is a reduction. And so our reduction, we divide. What do we divide 8 by to get to 4? And 4 by to get to 2? Well, it's a reduction divided by 2. So it is 1/2. Because we're seeing our number here divided by 2. That's literally what that means. So we have a 1/2. And then we'll see what's next. Oh. Make sure we click all the buttons. It'll tell us we have to. All right, for number 4, we have 2 triangles here. We need to decide which is our original and which one is our ending. And you were correct if you said this small triangle is our original image and this big triangle is our ending image, because the big one does have our B prime, C prime, and A prime. So to go from the small one to this large one, it's an enlargement. Correct. So let's look at our points and see what we're working with. Let's work with B here. So our original B is at, 4, comma 8. Hang on. This is getting on my nerves. All right. So our original B is at 4, 4, 8, and our B prime is at, let's see, what is that? 1, 2. So again, how do we get from 4 to 1 and 8 to 2? I did that backwards, guys. You're letting me slip. So our original B is at 1, 2. And our B prime is at 4, 8. Because this is an enlargement, and I could tell that I messed up, guys, because how can it be an enlargement if our ending numbers are bigger? Doesn't work like that. So our original B is at 1, 2, and we have an enlargement, so we know we're going to have to multiply here. So how do we get from 1 to 4? Well, we multiply by 4. That worked there. What do we do to 2 to get to 8? Well, we multiply it by 4. So our scale factor here, guys, is going to be 4. So we have 4. All right, here's our last one. Maybe I won't get mixed up this time. Let's decide which one is our original, which one is our ending. Well, our small triangle right here, FGH, it doesn't have any prime tick marks on it. So we know that this one is going to be our original. So if we're going from this small triangle to this large triangle, you got it. It's an enlargement. So let's figure out our scale factor. Well, what point do we want to use? Let's use G. So our original G is at 3, comma, I don't know why this is doing that. Let's see, let's try it again. Is at 3, comma, -1. And our G prime is at 15, comma, -5. So how do we get from 3 to 15 and -1 to -5? Well, this is an enlargement, so we know we're going to multiply. So our multiplication facts come into play here. What times 3 gives us 15? Well, heck yes, it's 5. So hopefully you got that. So this has a scale factor of 5. So remember, guys, on here we have to use each of our points and do a little bit of math to figure out which ones are which. All right, here is our next one. We got to sign in. So this one is in triangle congruent. So we need to use our notes from Unit 8, our Unit 8 notes, to go in and look at our postulates. Remember, we have side, 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 angle, angle, side, angle, 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 side, and the HL, which is hypotenuse leg. So we are going to look at these figures and determine if they're congruent. If we decide that they are congruent, we need to pick which of these postulates is correct. So let's look at number 1. We have 2 triangles. We can see that these 2 sides are marked as congruent. These 2 sides are marked as congruent. And this angle. So we have 2 sides and an included angle. So let's go to our notes and look at which one talks about 2 sides and an included angle. Well, hopefully you said that 2 sides and an included angle is SAS, side, angle, side, because our angle is in the middle. Number 2. Let's look at these 2 triangles. Well, let's look what we know about it already. Well, we know that these 2 sides are congruent. We know that these 2 sides are congruent. But what else do we know about this angle? Well, we know that it has a reflexive side. This side right here down the middle. Ooh, let's pretend I can highlight his line. So that we know that this line is the same length for both of these triangles. So this is a third side that is congruent. So we can tell that this is congruent because every side has a congruent side. So what is that called? Well, simply side, side, side. Number 3, we have 2 triangles. It's given us some information here. So we know that these 2 sides are congruent. We know that this angle is congruent. We know that we have these 2 angles that are congruent because they're vertical angles, and vertical angles are congruent. So do we have a postulate that we can use that has 2 angles and a not included side? 2 angles and a not included side. Well, that brings us to angle, angle, side, because we have 2 angles and a not included side. Number 4. Well, let's see what we already know. We have these 2 sides that are congruent. We have these 2 sides that are congruent. And we have another set of vertical angles here. And we know that they're congruent. So we have another case of having 2 sides and a not included angle. So what do we use here? Do we have a postulate that talks about 2 congruent sides and a not included angle? Nope. We are all out of luck there. So on number 4, let me clear this off. We don't have enough information because we need to have 2 angles and a side, or 2 sides and an included angle. Unfortunately, what they gave us here is not enough information. All right, let's look at number 5. So number 5, we know that we have a right angle going on here. We have this little box right here in the corner that tells us that this is a right angle. And if this is a right angle, guess what? This is going to be a right angle here on both sides. So we know that each one of these triangles has a right angle. We know that these sides are congruent. So when we have our right angle, remember our HL, we need to know that if the hypotenuse on both triangles is congruent, and then we need to know about a second side. Well, because these two are touching and they have this reflexive side right here, that means that this side is congruent too. This leg is congruent. So we have our hypotenuse, which is our side across from our 90-degree angle. They're both congruent, and we have a leg that's congruent. So on here, guys, we can prove this is congruent by the hypotenuse leg postulate. And then we just hit submit, and that's all we have. So if you guys have any questions about these, let me know. If you go work through them and you did get something wrong, you may go back and change your answers. I want you to be able to go back to this tomorrow when we're doing our short Show What You Know. So take a few minutes today and get this done. Have a great day.